You know, to really understand what makes our home, planet Earth, so special, we kind of have to leave it first. So today, let's take a journey through our cosmic neighborhood. It's a place of absolutely stunning beauty, for sure, but also incredible chaos and violence, and we're doing it all to come back with a new appreciation for the sanctuary we live on. And really, this is the big question, isn't it? We're on this planet that's just teeming with life, this vibrant blue marble set against this silent, black, empty space. So why here? What is it about this specific rock orbiting this particular star that makes it a haven when so much of the universe out there is completely hostile to life? And there it is, home. Looking at it from far away, it seems so peaceful, almost fragile, doesn't it? This is our starting point. We're going to venture out, meet some of our cosmic neighbors, and then we're coming right back here to really fully get what makes this pale blue dot so impossibly unique. Okay, so our solar system is way more than just the sun and the planets. It's actually a surprisingly busy place filled with this whole cast of other characters just zipping through the void. So come on, let's get to know our cosmic neighbors. First up, we've got satellites, or as we usually call them, moons. They're basically any solid body that orbits a planet. Our moon is, of course, the most famous example, but almost every planet in our solar system has at least one, except for Mercury and Venus. They're the odd ones out. And it's wild to remember, they don't make their own light. They're shining because they're reflecting sunlight, like giant cosmic mirrors. Next, we have asteroids. You can pretty much think of them as mini planets, just these big old chunks of rock and metal. Most of them hang out in a ring between Mars and Jupiter, which we call the asteroid belt. What's really cool is that they're essentially leftover building materials from when our solar system was forming. So studying them is kind of like cosmic archaeology. It's a way for us to look back in time. And then you have comets. People often call them dirty snowballs, and honestly, that's the perfect description. They're these clumps of ice, gas, and dust that cruise in from the coldest, most distant parts of our solar system. As a comet gets closer and closer to the sun, the heat starts to vaporize its surface, and that's what creates that spectacular glowing tail that can stretch for millions of kilometers across the sky. And right here, you can really see the difference. On the left, there's the asteroid, a solid, cratered hunk of rock, and on the right, the comet. It looks almost ghostly, right? It's this glowing object with that distinct, beautiful tail. One is a cosmic rock, the other, a cosmic snowball. Speaking of neighbors, our closest one, the moon, has a truly spectacular origin story. I mean, it wasn't born as some gentle companion. It was literally forged in a moment of unimaginable violence. So the leading theory is called the giant impact theory, or my favorite name for it, the big splat. Just try to picture this. About 4.5 billion years ago, a planet-sized object, maybe as big as Mars, just slams into a very young molten Earth. The collision was so huge it blasted a massive chunk of our planet's mantle right into space. This superheated cloud of rock and debris then got caught by Earth's gravity and formed a ring. And then, over millions of years, gravity did its thing, pulling all that debris together, clumping it up, until it formed the moon we see in our sky tonight. How incredible is that? Wow, that violent collision is a powerful reminder that our solar system is still filled with the leftovers of its chaotic past. And some of those remnants, those asteroids and comets we just met, well, they can still pose a very, very real threat. And the sheer number of these things is just staggering. We've cataloged over 100,000 asteroids. And get this, that's just what we've found so far. It really gives you a sense of just how crowded our cosmic neighborhood actually is. And this danger isn't just theoretical. As this quote reminds us, the most famous impact event in history, the one that wiped out the dinosaurs, is widely believed to have been caused by an asteroid collision. These cosmic wanderers have literally shaped the history of life on our planet. So what happens when smaller bits and pieces enter our atmosphere? Well, we get a light show. A meteor is that bright streak of light, what we call a shooting star, that we see as a piece of space debris burns up. But if a piece is big enough to survive that fiery journey and actually hit the ground, it gets a new name, a meteorite. So think of it this way. The meteor is the flash of light, the event. The meteorite is the actual rock you could potentially find and hold in your hand. Okay, so we've seen the chaos, we've seen the potential danger out there. Now it's time to come back home and explore exactly why our Earth is such a unique and protected sanctuary in the middle of all that. Today, we're so used to seeing these incredible pictures of our planet as a sphere, but that's a really recent thing. So let's jump back in time a bit and ask, for thousands of years, with absolutely no pictures from space, how did our ancestors figure out that we live on a giant ball? Well, one of the most elegant, earliest proofs came from just watching ships at sea. Ancient observers, people with a lot of time on their hands, noticed that as a ship sailed away, its hull would disappear over the horizon first, and then the mast would follow. Now, if the Earth were flat, the whole ship would just get smaller and smaller until it vanished. This bottom-up disappearing act could only happen if the ship was traveling along a curved surface. Pretty smart, huh? Another brilliant piece of evidence came from looking up at the sky. During a lunar eclipse, the Earth passes between the sun and the moon, and it casts its shadow on the moon's surface. What ancient astronomers noticed was that this shadow is always a perfect circle. It doesn't matter how the Earth is rotated, its shadow is always circular. And guess what? The only three-dimensional shape that always casts a perfect circular shadow from any angle is a sphere. Case closed. Of course, after centuries of these really clever observations and deductions, the debate was finally completely settled in the 20th century, when we could at last leave our planet. Because when it comes right down to it, the most powerful evidence is just seeing it with our own eyes. And the view, as you can see, is nothing short of spectacular. All right, now that we've confirmed our planet's shape, let's get to the very heart of what makes it a sanctuary. It's not just one thing, but a really precise combination of factors. It's like a perfect recipe for life. Scientists have a great name for it, the Goldilocks conditions. And the very first ingredient is location, location, location. The Goldilocks zone is the area around a star where a planet is at the perfect distance. Not too hot, not too cold, but just right for liquid water to exist. If we were any closer to the sun, all our water would boil away. Any farther, and it would all freeze solid. Earth is sitting right in that sweet spot. And that brings us to this perfect recipe for life. I mean, just think about how many things had to go exactly right. Our spot in that Goldilocks zone gives us this pleasant average temperature, which allows for these vast oceans of liquid water. Then you've got our amazing atmosphere, which does two crucial jobs. It shields us from the sun's harmful radiation, and it acts like a planetary blanket, trapping heat to keep our temperatures stable. That same atmosphere is also loaded with the oxygen we need to breathe. And finally, our planet's stable rotation makes sure heat gets spread around evenly so one side doesn't bake while the other freezes. It's just an incredibly delicate, life-sustaining balance. So we've journeyed through our solar system and we've come back home, realizing just how improbable and how precious our world really is. From its violent birth to its perfect cocktail of life-sustaining conditions, Earth is truly an extraordinary exception. And that leaves us with one final huge question to ponder. Our planet got the recipe just right, but how many other worlds out there in the vastness of the cosmos have done the same?